we're going to be discussing window operations on pandas datetimes. Let's take a look. In pandas, in addition to all of its datetime abilities, one of my favorite things that you can do with a datetime index in pandas is resample your data. But before we get to the fun of resampling and the fun of grouping on dates, we need to discuss the two of the ways that pandas represents dates. The difference between a date and a period is something you need to understand when interacting with pandas. A date in pandas is an actual specific point in time, and I say point in time. Whereas a period, as you can see on the bottom of my screen here, is a span of time, right? So both these data sets are on a weekly fidelity, but you can see on my top data set, I have every week, but technically that's at hour 0, minute 0, second 0, all the way to microsecond 0. Whereas in the lower portion of my screen, you actually see a data that's aligned on a period index. And you can see here that each period corresponds to a span of time instead of a single point in time. And so when we investigate a little bit deeper into what these look like under the hood, we see that in our date data, if we get that first value out of the index, we're actually dealing with what's called a timestamp. Whereas in our period data, we're dealing with a period. And a timestamp is just simply how pandas represents times under the hood, whereas a period is how pandas represents a period or a span of time under the hood. And now periods are slightly different than, say, an interval, which pandas also supports, but we'll get into that in a little bit. This timestamp object is very interesting because pandas uses it as a wrapper to interface with other datetime-like libraries in addition to NumPy. And so if we examine the features of these objects, we can see that I can use this asFreq to change the frequency of my data. And here you see that I'm actually getting a bunch of nans. And that's because I'm re-indexing my data with the days that are spread apart every 6. That's what this 6D. So I'm getting every 6 days from my earliest date in my data set, re-indexing that onto my new data or onto my old data set. And what's happening here is I don't have any values that correspond to January 10th or January 16th in my original data set. And that's why we get all of these nans. And so if I were to really explicitly show you, this is how pandas is actually performing this asFreq conversion under the hood. So we're just changing the frequency of the data. We're trying to re-index our original data onto this new frequency of our datetime index. This behaves quite differently than when we change the frequency of our period data. See here that when I use the asFrequency on my period data and I convert it to every 6 days, I actually lose no data. In fact, I keep all of the data, and I really haven't changed my index too much. Instead of being weekly, I'm going every 6 days, but my dates are still 7 days apart. And that's because we've changed the frequency of the period, but we haven't inserted any new values, any new periods, or actually altered the structure of the period index itself. And now this isn't very useful for when you're going deeper, when you're downsampling your data, or upsampling your data, but when you're downsampling, this actually becomes quite helpful. And when we change our frequency, right, we start at a weekly frequency. If we bump it up to a monthly frequency, we can actually see that we are in fact changing our index, and we can use this as a basis for performing group or windowed operations, because now I have an index who has 2 unique values instead of 10 here. Additionally, I can change the frequency to be quarterly instead of monthly. Monthly is what you just saw. And all of my data fall into a single quarter in this case. So you can see how the period index works and how we can change the frequency of it here. And if we want to do an actual windowed operation, all we need to really do is use pandas.resample method. It's crazy. It sounds like a very complex operation, resampling, but essentially all we're doing is we're taking our datetime index, We're binning it into any frequency that we want. In this case, this will be monthly. And just like with a pandas group by object, I can get the first value, I can get the last value, I can take the mean of all the values that fall into this bin, I can take the standard deviation, etc. And so I want to highlight just a slight difference here for you, where my resample to get the first date of the month might be different than just changing the frequency. Remember, when I just change the frequency, all I'm doing is re-indexing to my data. But this gets me the first observed value of each month. And so if you're going after the observed values of each month, this resample is actually the better way to go. This is a great way to guard against seeing all those nans that we saw earlier, because if your first date of the month happens, 1 second after 1 second after midnight, then this resample.first will actually still return those values and insert it into your monthly resampling. Again, it's just like a group by object. You can do .ag, and I can actually perform multiple aggregations over each month here. Additionally, if I had, say, some data here, and in this case I'm dealing with a multi-index on my rows, so I have 3 regions, and each region has some number of samples in terms of date times. And I have 2 columns. I have production and capacity. So we could be dealing with some, say, like power plant or substation type data where we are producing some amount of energy at some maximum capacity, right, that diverges from a theoretical maximum capacity. And so when we look at this data, we might want to perform different summaries. We might want to simply, group by the region and get the mean of both of our columns. That's very doable. We can do that, just with pandas-based group by. But what if we wanted to look at monthly averages? Well, we can do that again with resample. Just like group by, we can supply on or level. And when we're dealing with columns or part of our index, we want to supply the level keyword argument. And so I'm saying resample my data every month on my date index, right? That's what that level means. And then return to me the average of all my columns, all the values within that month. Additionally, I might want to actually do both. I don't just want to get the average for each region, and I don't want to just get the average for each month, but I want to get the average per region for each month. And so what we can do here is we can actually chain a call to resample onto our original group by. And by supplying our level keyword argument on our resample, Pandas knows to look into its own date time index, and I can extract the mean, and you'll see here that my data have actually been resampled per region into a monthly bin. There is another way to do this. You can actually stick within the group by method here. All you need to do is you pass region just as is, because that's how Pandas, passing a string into group by tells Pandas to look at the column or look at the index with this name and get all the unique groups. Then, for a second level of nesting, we can actually pass a grouper object. Under the hood, Pandas will convert all of your group by calls, all of your resample calls into these grouper objects. And we can actually supply a level, right? So where should we group on? And the grouper allows us to also supply a frequency. So I can, again, bin my data into monthly bins, nested within my regions, right, as specified by my group by, and I can calculate the means. This is the exact same as this above, just a slightly different syntax. And what you can imagine here is that you can pre-create these grouper objects. So if you had something like grouping rules, you could have a dictionary of rules, or I could just make a monthly grouping. And this would just be a grouper object, and I would supply on the month with a level equals date. And so this is agnostic of my data and only means something within the context of my data. But if I want to be passing around this grouping object, I can. which is fantastic if I want to perform multiple aggregations at various steps, or if I have data that has the same columns and I don't want to be creating a new string for my group by everywhere, all throughout my scripts. I can pre-create that kind of grouper and I can pass it around as I see fit. Additionally, pandas group bys are not limited to just jumping windows or windows that span unique groups of values. We can actually perform rolling windows as well. And now you typically will see a rolling window in date time analyses, time series analyses, I should say, and things like forecasting, where you have very noisy data and you just kind of want to smooth it just a little bit. So we can actually resample our data into bins of each day, right? And what I can do here is with all the data in the first day, I can calculate the mean. And then it'll shift to my next row in my data set, and it'll calculate a day from that row and bin all of the span of a day, or all of the values that fall into that day, into a mean. And it'll keep sliding. This is a sliding window that just slowly moves down my data set. And I can even span it, bin it into 3 days at a time or 7 days. But what I cannot do, I cannot span a week, and I cannot span a month. Now you can think about this, because a month is not a set period of time. Some months have 28 days, some months have 30 days. And so when I try to perform a binning operation onto the month that is agnostic of the month that it's in, we get this non-fixed frequency value error. And so whenever you're performing rolling operations, you should always stick with days, hours, or seconds. Additionally, you can perform a nested group by with a rolling window. I would caution you to just be careful when you're doing this, because you can hit a lot of issues, you can hit a lot of errors. Usually Pandas is very good about being aware of its own index. However, much of the code that supports our rolling operation is written in Python, and it is not as up to date as a lot of the Pandas library, unfortunately. And so when we're dealing with rolling operations, we actually need our date time index to be, or our date times to not be part of the index if we're nesting it into a group by. And so what you'll actually see here is that if I keep my date time index as part of my index, we actually get an error. And no matter how we specify this, the rolling cannot detect that I want to roll across the region. Instead, that I want to roll across my dates. Instead, we actually need to make the date the only index. And then we group on our region, and then rolling knows to automatically pick up from the only index. It does not handle multi-indexes very well. And so you can perform nested rolling operations within a grouping operation. Now let's apply this. Say I have a data set and I want to find the daily net charge. So let's take a look at the data that we're dealing with so we can put some context into that problem. Well, I can see here that I have some battery capacity data, and it looks like it's sampled very non-uniformly. I can't see if there's, every 19 seconds or every 10 seconds or 8 seconds. It looks very non-uniform. So if we wanted to analyze this data and find the daily net charge, what we could do is we could perform a vectorize operation first, and we could calculate the differences between each sample of our battery. And when we do this, we end up with a capacity diff column. And then from there, we can resample our data into daily bins, and we can actually take the sum of those differences. This is very similar to if I resampled and then took the first and last of the capacity and then subtracted them from each other. But we can see here that with just a couple lines of code, I'm able to perform a daily resampling of my data and look at some statistics or some results on a level on a daily level instead of on this non-uniform secondly level. And so I'm able to make much more sense of what my data is conveying. I can see that on May 1st, my charge went up by 8%. On May 2nd, I netted 1.2%. And then on the 3rd, it looks like I used my robot or my toy a lot, and I lost 7% net. And so we can actually do something a little bit more complex here. If I wanted to find the total charge time and total drain time per day. So if we look again at our data, we can see that there's multiple points in our throughout our day where our battery level is increasing or our battery level is decreasing. And that's what this diff helps us sort out. When I perform this diff, we can see that I'm subtracting the row in the second row, the value in the second row, from the value in the first row, and then the value in the third row from the second row, so on and so forth. That's what our diff does. We can actually look at the sign of that diff to determine, was our battery charging or was it decaying? And so when we do this, we can assign that value to, we can assign the positive or the sign of our capacity difference into whether or not it's charging at the same time. We can determine how much time elapsed, right? We can look at the rates of these things. So if my capacity dropped from increased from 73 to 75 between my first two measurements, I can measure that in my capacity diff, but I can also measure how long that took by taking the difference of my measurements or my date time index here. From there, I can perform a nested group by with resampling, and I can actually save that. I can actually group by whether or not it was charging, and then resample by the day on my measurement. And I can perform this, and I can examine my results, and I can see that when it's not charging on the May 1st, I can see that I actually ended up using 273% of my battery. Now that doesn't make sense, right? You can't use up more than 100%, but you can think throughout the day, I was using a little bit, and then I was charging it, and then I was using it, and then I was charging it. And you can actually look at this, and you can compare it with the time that it was charging on that same date. You can see that I went up by 281. If I were to take the difference of these, I would get that difference of 8% that we saw in the analysis above. And so if I were to look at this and just tidy these results up just a little bit, I like it when my charging is nested within my measurement instead of vice versa. And so now here I can very neatly see that when I was not charging, I lost this much capacity, and when I was charging, I gained this much capacity in total. And you can see the number of times, right, that I switched from charging to not charging. And you can also see the total amount of time that my battery spent draining versus the total amount of time that my battery spent charging. And so with these metrics, we could do things like calculate decay rates or charging rates, but I will leave that fun for you to explore, as this answers the question that we had set out to answer.